So hello and welcome. Today I'd like to talk about ways of taking pictures with a microscope. I'd like to show you all of the different ways and methods that I tried out during the past years to make pictures. Yes, and I'd just like to share my experience with you a little bit, and I'd also like to show to you some of the cameras that I actually used. So let's get started over here. This one was one of my first microscope cameras that I had. It's a USB 2.0 eyepiece camera, so this means that you can take it and you can plug it in directly into the microscope instead of an eyepiece. It has over here a so-called a reduction optics, so that means that the sensor is inside the main body over here, and this part here, this extension over here, are actually optics that make sure that you get a larger field of view. And basically what happens is the following: you just take off the protective cap, you take out the eyepiece, and you simply plug it in like this, and then you have a USB cable connecting to your computer, and then you can take pictures using the computer. Very practical. It's for example, if you want to take time-lapse pictures, if you set an interval every, I don't know, 2 or 5 seconds, and then it's able to take the pictures, and it's going to write the pictures directly onto the hard drive of the computer. Having said that, there are a few disadvantages to the system, and one of the disadvantages is that this camera is not suitable to make videos because the USB 2.0 connection is too slow to transmit high quality video. So yes, you are actually able to record videos, but these videos are going to be very small in size, or they have a small low frame rate, and it's a little bit, I don't know, it's not so nice. It did not work very well. So I've used this only to make still images. Having said that, these USB cameras, because they have a relatively small sensor, so there is a little bit of noise there, and also the so-called dynamic range of the camera is not very high compared to the better cameras. The reason being, with dynamic range I mean that the camera is not able to capture both bright and dark areas at the same time. So if a region is a little bit dark, it's going to be completely dark, and if it's a little bit bright, it's going to be completely white, and you lose details in the bright and in the dark areas. So this is a somewhat of a disadvantage, but it's I would say a very convenient way. This one has 2.3 megapixels. So that is, I've been fine for actually using the pictures here. If for the internet, if you just want to post a few small pictures, it's fine. Probably not very good if you want to make high quality prints, large prints. Okay, so these are actually more cameras that are used, in the industry, for example, or in maybe routine medical research, and also useful if you just want to transfer the picture live to a computer, and so that you want to do microscopy on the computer screen. These are actually useful. Now, because I actually wanted to take videos, I was looking around for a USB 3.0 camera, and I did find one, and it's a very small one. It's really incredibly small. I was quite surprised myself of the small size. There are, a few interesting fundamental differences here. First of all, it does not contain any reduction optics in front. So this means if you take off the protective cap, the sensor is quite, actually the barrel up here, it's quite far in the front. It plugs into the microscope just like the other camera does. USB 3.0 cable is needed. You gotta get the right cable, otherwise you don't get the transmission speed. And yes, it is able to deliver a high frame rate. However, there is a problem, and I was actually not very satisfied, because not the camera was the problem, but my computer had a USB 3.0, of course, but the camera always dropped back to the USB 2.0 speed. And I did some research online, and I discovered that not all computer manufacturers implement the USB 3 standard correctly, apparently. So there were some compatibility problems. Now, I don't know the reason. I was not able to resolve it. I thought it was a driver issue, so I downloaded new drivers. It did not resolve the problem. So I was not very successful. So I was able only to film, let's say, a few seconds on a very high speed, and then it always dropped back to the lower speed. So a little bit unfortunate. Another interesting thing here is the following: is because it does not have any reduction optics, the field of view is really not very high. So this means is you're actually only looking at a very small part of the field of view. So you're so this camera essentially also magnifies the image more than what you're probably used to. So that is basically these were the two USB cameras, 2.0 and 3.0, and then I also tried a few other things here, and I tried to connect a mobile phone to my microscope, and so I got this mobile phone adapter over here. And this was a really interesting concept. Actually, it is from an adapter which is not used only for microscopes but also for telescopes, and it works like this. It has this screw-on part here, and basically it is like this. If you turn this, then you can see that there are 3 of these clamps moving inward, and what they do is they should grip the eyepiece. However, because microscope eyepieces are a little bit smaller than telescope eyepieces, it's like this, that it didn't really fit, and the eyepiece was a little bit too narrow. So that was a problem. So maybe this can be resolved by wrapping around a few, I don't know, maybe a few layers of cardboard or something. And then if you use larger eyepieces, however, then you have a similar problem, but on the other extreme, in that it does not grip properly because the 3 extensions don't move inward very well. And it's still not a very solid connection. So that is a little bit the problem that I had with this one. But I did find a solution, and the solution was the following. I took an eyepiece and I wrapped a few layers of cardboard around it, and then I used this here, and I pressed everything into the adapter, and then I had a stable connection. On the other hand, on the other side over here, what you have is you have to buy yourself, for your mobile phone, you have to buy yourself a mobile phone cover, and you have to glue this part in the front. You have to glue on here, and there's some Velcro that came with it. And then when you screw the top on, then you can actually take the whole thing and you can put it as it is on your microscope, like this over here. Okay, so you see that now it's actually quite stable, and it should work. Okay, so this was essentially, yes, this issue with not the ability to have a proper size in here. So so the size was a problem. The microscope eyepiece was simply too small, and so I solved this with a little bit of cardboard. And then it works. Okay. Of course, what you still have to do, the eye relief, you have to move the eyepiece in and out a little bit to adjust the proper distance. So that is another one that I used, and the next one, not manufactured anymore. This is called the Skylight Adapter, and this Skylight Adapter is also a mobile phone adapter. It looks like this over here, and over here on the other side you can actually see this place over. It's quite large, and this is basically where the eyepiece goes. Now you're going to say, how does this work? Because it's so large over here, and that's why this adapter came along with a few of these rubber strips, and they are there to be wrapped around the eyepiece like this, and then the whole thing is to be mounted and can be clamped. I'm not going to do this now, but I guess you get the idea. It goes in there, and then you can tighten the screw, and it's supposed to clamp. Okay. Now the concept of this is that it is movable in several directions. So you can center the camera. So the mobile phone goes in front here with the camera pointing into this direction over here, and then you can actually center it by moving it back and forth, up and down. Okay. It worked. The thing only is that because of the weight of the camera, of the mobile phone, the whole thing started to slide down slowly, and I resolved this problem by actually taping it. I just applied a little bit of tape on the other side, and then it was stable. Also a workable solution, and then it looks a little bit like this. So that's basically the idea with the mobile phone on front here. I don't have a mobile phone. Oh, here it is. Okay, the mobile phone goes in here, and camera is over here on the other side here. Okay, and you have to center it somehow, and then the idea is that basically you're able to do microscopy this way, and you also have a screen here where you can actually see directly what you're filming. So that is the other one. This was the Skylight Adapter. And over here I've got a homemade solution that's with afocal photography. So basically, yeah, that's pretty self-explanatory. This goes on top of the microscope, and over here I've adjusted the camera, getting the right distance and everything. This was a little bit a delicate issue, so I had to do a very careful measurement and to get everything aligned, because in this afocal photography, this is a very delicate thing to get everything aligned. Otherwise you don't get a proper picture. I only used this experimentally for a few days, and then I bought myself something that was quite happy with, a dedicated clamp for afocal photography, and this one actually works quite well, and it is very solid. Okay, and it is suitable for a variety of different camera sizes. I'm going to make a separate video of this because I think it deserves a little bit separate treatment here, because it is actually very workable and a good solution, I think. And it is like this, that over here you've got, now I moved the microphone. You've got over here the eyepiece, and I clamped it in, so it's staying like this. So I bought myself a separate eyepiece simply to be fixed in here, and then the camera, of course. Now the nice thing about this this system here is that the threading for the of the camera, I'll remove this here. Okay, the threading of the camera for mounting the clamp and the lens, they do not have to be aligned. Okay, so that is the cool thing, because you are still able to align the eyepiece with the objective of the camera, because all you do is you make sure that this bar goes diagonally, and then it's still aligned. Okay, so this is the reason why I like this is because it was relatively low cost compared to the other solutions. It gives you very good results. You can do video with this, because if the camera is able to do high definition video, then you can record video, and you have also a zoom function of the camera. So this means you can actually get a very wide field of a view, and you can also zoom in more. So in that sense, it's very versatile in that sense in what you can do with it. It doesn't look quite as nice maybe having it connected over here to the microscope. It's a little bit, I don't know, all of these bars sticking away and all, yeah, but it doesn't matter really. What counts is that ultimately you have a nice picture. And of course you can also see that you can now use the camera as well, the screen of the camera as well as a monitor to actually do microscopy over the screen directly. Okay, so that is basically the thing, but as I said, I'm gonna make a separate video maybe on this clamp later on. So having said that, let me replace this eyepiece over here. I'm now gonna move over here to this microscope over here in the back, because this one has now probably the most I would say, yeah, the best solution. Yeah, best. What's best? I mean, it's the most expensive one, but maybe the one that also with the best image quality. Okay, so let's have a look at this in more detail. So this one up here is a digital SLR camera, and it is a full frame camera. It's the Canon EOS 5D Mark II, very expensive. It's a professional grade camera. And it has a full size sensor. This means, yeah, like film size. This means we have a very low signal, very high signal to noise ratio, of course, and we're covering an extremely wide field of view. So this means that we're actually covering a very large area at a very high quality. The dynamic range of the camera is excellent, and yeah, I think there is no better way of getting a picture. What is the disadvantage of the whole thing? It's horribly expensive, okay, because you also need this adapter over here. I think it's not manufactured anymore, because the Olympus has changed the system now from, this is still the old 160mm standard, and now they've changed to infinity optics, so this is not manufactured anymore. But you can still get stuff like this used on eBay, but it's not cheap. Okay, so I'm going to show you how this actually is set up right now. You need a trinocular head, because the weight of the whole system is simply too high. You cannot attach it to an eyepiece over here. That's not going to work, simply out of weight reasons. And what I'm going to do is I'm going to carefully take this apart. Okay, I'm going to remove this top adapter tube over here, and what we see in here, I'm going to carefully take this away. Okay, So this, now I think I'm gonna put it like this carefully. So, and what you see in here is a photo projection ocular. So this is not a regular eyepiece, but this one is designed specifically for photography work. And it is a so-called compensating ocular. What this means is that it compensates and corrects all of the lens errors from the objectives. Okay, there are some kind of spherical aberrations and some lens errors, and this one is corrected and is designed to project an image onto film, or in this case now, because we're using digital cameras nowadays, onto the sensor of the film. Okay, so this is how it looks like, yeah, this is a so-called a compensating ocular or compensating eyepiece, and they are they're not made anymore, so they're really difficult to get, and it only makes sense to get them if they're actually manufactured in or compatible with the objectives of the same company, which are down here. Okay, so they cooperate. Okay, having said that, this gives the best results, and just to did the math recently. I mean, I've got this, how much I paid for this. This tube, I mean, I bought this about 20 years ago when it was still manufactured, but I did the math, and this tube alone was about 3 times as expensive as one of those student microscopes as I have over here. So you can get 3 of these things here for this tube with the compensating eyepiece in here. Okay, so that's simply yeah, for comparison. Having said that, it's really probably it gives the best results. Now this one over here is a so-called a full frame DSLR. You can also use the lower cost cameras. I've got a second DSLR which has a smaller sensor. Also works fine. Also is great. As a matter of fact, I'm using this camera right now to film myself. That's why I cannot show it to you. But it is like this, that with a smaller sensor you don't get the same field of view, so that is a little bit a slight disadvantage. So, but with this one here, that's yeah, I think you can't get in much better, but at the same time it's a little bit, I would say, large and clumsy and not very practical. So portability certainly is not possible now anymore, and the price is very high. So that is simply a factor to be considered. So therefore might not be, I would say, suitable for amateur use. Having said that, I think this one over here is, yeah, is much more, how shall I say, for them, the price to performance ratio of this system is much better. Okay, because you pay the fraction of the cost, and you get results which are also extremely good. So very useful and very good results with a system like this here. So yeah, but at that time, 20 years ago when I bought the microscope, these compact cameras were not around yet. Okay, so this was designed actually for film cameras, and that's why I had to get this here, because at that time this was the only thing that was available. Okay, but times have changed nowadays, and now we're a little bit more flexible, and now we can also use compact cameras which are able to film. It's really great. I mean, not imaginable a couple of years ago. Okay, so this was basically it. This kind of should have given you a slight overview of what systems I'm using, but at the very end I still have to show you something, a slight trick, because I think I want to just show you how you can use a mobile phone now to take a picture without any adapter at all. It's a little trick that I basically occasionally use when I don't have an adapter around, just to quickly document something, and that's what works like this. What you do is the following: you grab one of the eyepieces, or I'm going to use the other microscope, I think, because it's a little bit easier. My other, okay, because that's okay. Can you see this? Yeah, okay, now it's in. I've got to check in the camera. So what you do is the following. Here you have the camera, and you wrap your fingers around the eyepiece like this, but make sure that it's not too far down, but it's got to be a little bit up, because you have a so-called an eye relief. So, and then what you do is you take this here and you place it on top here. Okay, so you have a rest. You're resting the camera on your fingers over here, and this gives it sufficient stability, and then you can use your index finger to release the camera. Okay. Otherwise, if you're trying to hold it like this, is not going to work, because you have to keep the distance correct, the x and the y axis, the tilt has to be correct. It's almost impossible to get a picture like this, but if you do it like this, you have a possibility to get a picture. Okay, just a little short trick at the end. Okay, and yeah, and I just wanted to show you also now two images or two short films of a tick, once using the full frame. The full frame Canon EOS 5D Mark II, and then the somewhat smaller EOS 600D with a smaller sensor, simply to see, show you how the field of view changes depending on sensor size. Okay, but that was pretty much it right now, and now let's have a quick look. And I wish you a nice day. But now just stay tuned a little bit, because I'm going to show you the film now. Okay, all the best. This is now using the camera with the large sensor size, so the 5D, the Canon EOS 5D. You can see that the full tick is able to fit basically on screen all at once. And now this is the 650D. This has a smaller APS sensor, and now it's not possible anymore to image the whole tick at once. And so you can see that it's much significantly enlarged. Okay, this was it. I wish you a nice day, and bye bye.